uh, November 15, 2019. Time is 12:20 p.m. Abu Dhabi time. Question is, in a hypothesis testing, a p-value of 0.1 indicates that choice A, there is extremely strong evidence that null hypothesis or H0 or H0 should be rejected. Choice B, there is a probability of 0.1 of observing a sample value at least as extreme as the value observed. Assuming null hypothesis is correct. And choice C, there is a probability of 0.1 of observing a sample value at least as extreme as the value observed, assuming H0 is rejected. Here, they're not quantifying it. In statistics, you cannot do this. So, for me, this is right away you can eliminate. It's either this or this one. But before answering that, we have to understand what is a p-value of 0.1 is. So if you draw this bell curve, you'll have, let's say, assume it's a normal distribution. This is the mean, median, and mode here. Assume it's of course symmetrical. The p-value is the how do I explain p-value? You have a critical value, which is the level of significance. Let's say, assuming our level of significance, I'll just write it in full. Significance. Poor handwriting. This is your alpha. Right? And this one, ignore this for the time being. We don't know the null hypothesis, what it is. Let's say, I'm assuming it's a two-tailed test. Now, level of significance. Now, how do you get the level of significance? The level of significance is 1 minus the confidence interval. In statistics, they will say, I am 95% confident that blah 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 is this and that. Okay? That 95% confidence interval, let's say you'll have 95% confidence interval. How do I explain this? So I'll erase it after, like this. It's like this 1 standard deviation. This is 2 standard deviations, or 1.96. 1.96. 1 standard deviation, 2 standard deviations, or 1.96. Approximately 2. 2 is the 2 standard deviations away from the mean is your z value is 1.96. That is the exact. The approximate is 2. So it means your alpha will be this area. Alpha. Right? Okay, alpha is this area here. Correct? So if it's a two-tailed test, you have to divide alpha by 2. Because it's a two-tailed test. If it's a one-tailed test, you don't have to divide alpha by 2 because it's a one-tail test, and that will be covered in a separate video. So now we know our level of significance, right? This, and we will get our alpha. 1 minus confidence interval is equal to alpha. And this is also the critical value. Critical value. This will determine whether we will reject the null hypothesis or we will fail to reject the null hypothesis. Right. So what is a null hypothesis or H0? So let's assume it's a two-tailed test. A null hypothesis will have an equal sign. This is part of my CFA level 1 review. So let's say the mean, the mu is equal to, the null hypothesis will have an equal sign. It's either greater than or equal to sign or less than or equal to sign. If it contains greater than or equal to sign, it means it's a one-tail test. So let's say average is, let's say 10, right? This is the mean, 10. And of course, the null hypothesis, the alternative hypothesis is not equal to 10. Just for example. Okay. Now, this is the rule. And you say, why you have penis here? Right? This is how I got it. P-value. The p-value or probability value is the level of marginal significance within a statistical hypothesis test representing the probability of occurrence of a given event. A p-value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. A smaller p-value means that there is a stronger evidence in favor of the alternative hypothesis. A smaller p-value means there is a stronger evidence in favor of the alternative hypothesis. And this is where I got those stuff there. If P, I want to say P, the word P is small, you want to reject the null hypothesis. If P is big, then accept the null. You see the alpha here? This alpha is the 1 minus level of significance. Okay, so let's see here. P, what is the p value? P value is 0.10 here in this problem. 0.10 or 10%. If 10% is here, what do you think? And our critical value is here, or alpha. I use different colors here. Or this is the alpha. It's a two-tailed test, so divided by 2. Right? And it is symmetrical here as well. But remember, p-value is both of them. This side, p-value. You have to add both. So if I want to say p-value is 0.001, oh sorry, not 0.001, p-value is here is 10%. So if I want to split it, if I'm doing two-tailed test, I have to divide it by 2. So therefore this should be, if I divide it by 2, this one, should I divide the p-value by 0.2 as well? Value, right side will be 0.05, right? This will be there will be a symmetrical p-value here. It's not symmetrical how I drew it. See, p-value is here. This is p-value, left side. .05 or 10% divided by 2. Now, what we will do? Now the critical value or alpha divided by 2, let's say it is 5%, for example. Because I mentioned here 1.96. 1.96 is equal to 95% confidence. So this at 95% confidence interval, so it means 2.5%. This is right side p-value, which is this is divided by 2 as well, so this is 2.5%, and it is greater than alpha. So what did we say here? If p-value this is 5%, right? 0.05 or 5%, but in the problem is 10%. So if p-value is greater than the alpha, you have to accept the null hypothesis. Accepting the null hypothesis or node means fail to reject, right? If it's fail to reject your null hypothesis, you are saying that the null hypothesis is true. Null hypothesis is true. Again, p-value is one side only, is 5%. In the problem, it is saying 10%. Right? So this one is 5%. And my alpha, or critical value, divided by 2. Remember, I have 95% confidence interval. So 1 minus confidence interval, 100% minus 95% is 5%. Divided by 2 is 2.5%. And this one is higher. If P blip 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 is higher than the alpha, then accept the null hypothesis, or fail to reject. Accept or null hypothesis, which means fail to reject. Null hypothesis. So you're saying if you fail to reject the null hypothesis, it means null hypothesis is correct. So look here. This is like a summary that I skipped. If p-value, the shaded ones, is greater than the level of significance alpha, which is 100 minus 95%, 5%. In our problem, this is 10% and this is 5%. Right? So you have to fail. Since pennies is greater than the alpha, you have to accept the null hypothesis, which means fail to reject the null hypothesis. So you're saying the null hypothesis here is correct, and therefore you should fail to reject it, or you should accept the null hypothesis. So in this case, what I did is, I am assuming it's a two-tailed test, so I divided it by 2. So if you divide your alpha by 2, you should divide your p-value by 2 as well. Or simply compare the p-value, which is it's mentioned here. P-value is the level of marginal significance within a statistical hypothesis test, representing the probability of occurrence of a given event. So probability that, let's say it's either it's a two-tailed test, right? So probability of not equal will be on both sides of the tail, because it's a two-tailed test. So it's the sum of the two. It's the probability of the event occurring. So you can either compare the 10%, the p-value, which is both sides, which actually here I don't know the null hypothesis, I'm just assuming, and I want to highlight this point here. I think that's it, right? Most candidates gets confused here. They say fail to reject the null is the same as accepting the null hypothesis. If you accept the null hypothesis, it means that the null hypothesis is correct. So that causes the confusion. So thank you for watching this video.